Okay, so now I'm going to show where these rules come from. So it says use the derivatives of sine and cosine from above and the quotient rule to show that tangent of x, the derivative of tangent of x is equal to secant squared of x. And so how I'm going to do this is I'm first going to rewrite tangent as sine over cosine. Remember we talked about that above here in the rule number 4 that I added. Okay, and so I'm going to rewrite it as that, and then from there, since I have a quotient of two functions, I can apply the quotient rule, and that will help me get to the right-hand side of showing that this is secant squared of x. So here, I'm going to just say to you to note tangent of x is equal to sine of x over cosine. And so now I want to say tangent of x, the derivative of that, is equal to the derivative of sine of x over cosine of x. And so now I want to apply the quotient rule. And so I remember that it's the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And so if it helps you, you can think of low d high minus high d low all over low low. Alright, and you get the same answer. So here, what I'm going to do is actually take the derivative of sine and cosine, so that's where I'm using those derivatives above. And so remember, I think of Santa Claus, so SC, and how sad I get when the season's over. So I'm happy when the season's happening, that's why it's positive, and then I get sad when it's over. So from here, I know that the derivative of sine is cosine, and the derivative of cosine is negative sine. And so I get that this is cosine x times cosine x minus sine x times negative sine x. And then this is still all over cosine x squared. Okay, well this is just cosine squared x plus sine squared x all over cosine squared x. Okay, so all I did is I said, okay, cosine x times cosine x, that's cosine squared x, and then negative sine x times negative sine x gives me a positive sine squared x, and then all over cosine squared x. Okay, so now you want to remember that cosine squared x plus sine squared x, that's truly like the most important identity in pre-calculus. All right, that is equal to 1. And so I get that this is 1 over cosine squared x, which is equal to secant squared x. Okay, because remember that secant x is 1 over cosine x, so secant squared x is 1 over cosine squared x. And so if you're not completely convinced of this, I can show this out more to convince you. Alright, so 1 over cosine squared x, right? This is equal to 1 over cosine x times cosine x, which is equal to 1 over cosine x times 1 over cosine x, which is equal to secant x times secant x, which is equal to secant squared x. And sorry I blew through that fast, but let's highlight. Alright, so 1 over cosine squared x, I just said, well, by definition, that just means cosine of x times cosine of x. Just definition of exponents, right? You would tell me x squared is equal to x times x. Okay, so then from there I go, well, this fraction that I have over here, that's just equal to 1 over cosine x times 1 over cosine x, right? If I multiply back these two fractions, I get exactly what I have on the left. And so you do exactly from the top get that 1 over cosine x is secant And 1 over cosine x is, of course, secant. So I have secant times secant, which is secant squared x. Okay, and so most of the time when I just say, okay, secant squared x, that's 1 over cosine squared x. So I immediately jump to that. But if you're not completely convinced, you can just like convince yourself with what I just did, highlighted in red. And so that's how you like truly can be convinced of that.